a balanced chemical equation tells how many units of each atom, molecule, or formula unit are present, and how many are needed to form a specific product. So in a chemical equation, you're first usually going to have coefficients. Now, you don't always have coefficients, but many times you do, and you have one or two of them in this equation right here, a 2 here and a 2 here. So those are coefficients. Now, this little number right here is a subscript. And if you think about the prefix sub, like in submarine, it means below. And so if you think about the word subscript, it also has the prefix sub, which means it's below. And you can see how it's smaller and below here. Now, a coefficient is as big as the other letters. And so that's a coefficient right here. And it becomes before the molecule or before the atom. And it tells you how many of something that you have. So it's different than a subscript in that right here, this subscript means you have 2 chlorine atoms together in a molecule. So you have a chloride molecule. Now over here, you don't have 2 sodium atoms together in a molecule. Instead, you just have 2 sodium atoms doing their own thing floating around. So that's what the 2 means here. You have 2 units of something. And so right here you have a sodium chloride molecule, and it means you have 2 sodium chloride molecules. Now, for the purpose of counting atoms to make sure you have a balanced chemical equation, make sure that you apply the coefficient to every atom in that molecule. So this 2 right here means you have 2 sodium atoms, and it means you have 2 chlorine atoms. So the next thing you're always going to have in an equation is an arrow. I'm going to put an S in parentheses here because sometimes you have more than one. And an arrow just shows the direction of a reaction, and it's going to move from the reactant side of the equation to the product side. So here's the reactant side because these are the things that are reacting together, and here's the product or what they formed. Now sometimes you may have 2 arrows pointing in opposite directions, or a double-headed arrow where it's one line but there's arrowheads pointing in both directions, and that shows that it's a reversible reaction. Now next we're going to get to the subscripts. So we only have one subscript here, and it's right here. And I kind of already told you what that is. Now, sometimes you don't have a subscript. Like right here, you don't have a subscript. Well, when there's no subscript, you can just assume that you could actually put a 1 there. So we could actually write a 1 right here, and that would mean there's 1 sodium atom there. But it's kind of an understood 1. You don't really need it there. And the same thing with coefficients. Right here, you don't have a coefficient, but it's an understood 1. So you could just put a 1 right there, and it would be the same thing as not having a 1 at all. So now, finally, we need to make sure our equation is balanced. And remember, a balanced chemical equation tells how many units of each atom, molecule, or formula unit are present and how many are needed to form a specific product. And so this right here tells us how many are needed to form a specific product. Because to get a sodium chloride molecule, you need 1 sodium and 1 chlorine atom to join together. And see, since we have the coefficient of 2, it means we have 2 sodium chloride molecules, but it shows us that really you can have, see what that coefficient is telling us is that we have 2 sodium chloride molecules looking like that. So you only need 1 sodium and 1 chlorine molecule, or 1 sodium and 1 chlorine atom to join together to form sodium chloride. So that's what it means when it says how many are needed to form a specific product. And a balanced chemical equation does tell how many units of each atom, molecule, or formula unit are present. And we can look right here and see that we have 2 sodium atoms over here and 2 sodium atoms over here. We have 2 chlorine atoms over here, and we have 2 chlorine atoms over here. And so this is a balanced chemical equation because we have equal numbers of each atom on each side of the equation. So this equation is balanced, and if there are equal numbers of each type of atom on the left and right sides of the reaction arrow, then it is a balanced equation. Now, a balanced equation represents the law of conservation of mass, which states that in any chemical or physical change, matter cannot be created or destroyed. So if you were wondering why we have to have the same numbers of each atom on the left and right sides of the reaction arrow, it's because matter cannot be created or destroyed. So whatever on the reactant side of the equation must somehow be factored in to the product side of the equation.